In section 5.4, we're going to look at what's called a general approach to factoring. Basically, it's covering how do we know what type of factoring to use and when. Now, they have a whole list of your different options that we've talked about, which is we've talked about finding your GCF, your greatest common factor. We've also talked about how to deal with squares and cubes. Remember, with squares, we could only do squares if it was a difference, meaning a minus sign. And cubes, we could do both, but it was a SOAP process where you have a binomial, a two-piecer, times a three-piecer. So you would have a binomial, two pieces, times a trinomial, three pieces. We also talked about how do you factor three terms. We talked about that we would actually use what you use for four terms, which was grouping, by starting out by using AC method. Then we would break it up into a grouping problem by breaking up the two middle factors. And the key, though, is to always make sure that you can't go any further, is to make sure that we have nothing in common and that everything that we can is done, that it can't be factored further. However, I think the best kind of way to look at this is the following flowchart. The following flowchart says, start at the top. No matter what, the first thing that you should always be looking for is your greatest common factor. No matter how many terms you have, the first thing you always want to look for is, what do my pieces have in common, and factor it out. Now, after you've pulled out a greatest common factor, it does not necessarily mean you are done. Your second step is going to be one of the following. It's going to be based on how many pieces you actually have. Do I have four terms? Do I have three terms? Or do I have two terms? Well, if I've got four terms, we talked about this right away. If you have four terms, you're going to be doing factoring by grouping, meaning grouping the first two and grouping the second two. You pull out a greatest common factor. Then you get another common factor that you pull out, and everything works out perfectly. Then we also talked about three terms. If you've learned guess and check, you can use that if you like it. But we learned AC method, which is you take your A times your C. You figure out what two things multiply together to give you the middle number. And then you break up your middle term so that you can do four terms so that you'll have a grouping problem again. So we've done four terms, three terms, and then the last thing that we did was, what if you have two terms? Well, we said if you've got two terms, you've either got squares or cubes. We said you can only do squares if it's a difference, meaning there's a minus sign. We said that if there is a sum, meaning a plus sign in the squares, you can't do it. It's called prime. But we said if we have cubes, whether it's a sum or a difference, you can do either one. So, how did you do either one? Remember, we did a binomial times a trinomial, and then for the signs, we did the SOAP thing, which was same, opposite, always positive. Again, that's same, opposite, always positive. So the goal is, in this section 5.4, is that they're going to have all the problems from sections 5.1, 5.2, and 5.3, and then we're just going to hit the scramble button on them, meaning they're all going to be mixed up, which is exactly what they would do on a test. They're not going to tell you what kind of factoring to do. You're going to have to take a look and say, oh, they're just telling me to factor. Uh-oh. And have to mentally look and say, oh, well, they don't have anything in common, but I do see two terms, so I know I'm definitely looking at either squares or cubes. Or, oh, I see something that's in common between all three terms. Let me pull that out first before I even think about doing AC method. So that's kind of our idea. We want to be able to look at our problems and without any real difficulty be able to say, I know how to start these problems, because they're all going to tell you to do factoring, but they're not going to tell you to do what kind to actually do. And that's what you need to be prepared for on your test and in your homework. So I'd say the best homework section to study is this one, 5.4, because it's all the previous sections just scrambled up. This would be a good section to put away your notes and to see what you know before you actually get to the test, is to put away all your notes and see how much of the factoring you actually can do on your own. Let's start with the first example, problem A. In problem A, we've got, let's see, x to the fourth minus, so x to the fourth minus 16. Well, first of all, I don't see anything in common between both terms, so then I'm going to move on to the size. Well, the size is that we've got two terms, so it's either going to be squares or cubes. Now, because of the fact that my exponent is only divisible by 2, I know I'm definitely looking at something that's going to be a squares, which is perfect because I do have a minus sign. Remember, I can only factor squares if there's a difference of a subtraction sign in the middle. So then I need to decide what's squared in each piece, or what do I need 2 of? Well, how do I get the x to the fourth? Well, I need 2, or to square an x squared. And what do I need 2 of, or to square, to get 16? Is the number 4. So what that will help me now do is factor out my difference of 2 squares. In both slots, I'll have an x squared and a 4. It's just, remember with squares, you'll have one that's a plus and one that's a minus. However, we're not done. Notice we still have squares. X is squared and 4 is 2 squared. So because we said you can't do anything with a sum of squares, that first piece will stay the same. It will stay as an x squared plus 4. You can't break that down again. But we said you can break down a difference of 2 squares, so we're going to have to break down that last one more time. Well, what's squared in the first piece is an x, and what's squared in the second piece is a 2. So what that's going to do is split us up into 2 more pieces, an x and a 2, in both. And just like before, one will be a plus and one will be a minus. So that is our final answer, all 3 pieces. So we actually had to use squares not once, but twice. Let's take a look at problem B. In problem B, we have x squared. We have x squared minus 6x minus 16. And what we notice right away is that there's nothing in common between all 3 terms. So then the question becomes, what do we do with 3 terms? Well, remember we do AC method, so we need an A, B, and C. Remember the A is hidden here, it's a 1. So our AC method tells me to do A times C, which is 1 times, be careful, negative 16, which gives me a negative 16. And then I'll need 2 factors of negative 16 that add up to a negative 6. Well, the only way to get a negative 16 is if one number is negative and one number is positive. And I need 2 numbers that when I add up, they get a negative 6. Well, that's going to be a negative 8 and a positive 2. So what that lets me do then is break down that middle piece, the negative 6, into a negative 8 and a positive 2. So let's go ahead and do that. So that will break down my negative 6x into a negative 8x and a positive 2x. The first part, the x squared, will stay the same. And the last part, the negative 16, will also stay the same. But at least now what I have is 4 terms, so I can do grouping. So I can group the first 2 and say, what do I have in common? I have a common factor of x, and pull that out, which will leave me with an x minus 8. And then I can do the same thing with the last 2 and pull down my plus sign. which is that the last two are both divisible by 2, so I can factor out a 2, which leaves me with an x minus 8. Now, notice we have a matching x minus 8 between both, so we are doing wonderful. They match up like we need. So I can factor out the matching x minus 8, parentheses and all, which will leave me with leftovers going inside of their own set of parentheses as x plus 2. And that is it. That's our final answer for B, is an x minus 8 times an x plus 2. Let's try another one. Let's take a look at problem C. In problem C, let's see, we've got a 2x squared minus 7x minus 4. So again, we have 3 terms. Nothing is in common between all 3. So I'm starting out with AC method because there's no greatest common factor. So I need to figure out what my A, B, and C are. Well, my A is going to be 2, my B is going to be negative 7, and my C is negative 4. So I start with my A times C, which is a 2 times negative 4, which is equal to negative 8. And I need 2 factors of negative 8 that are going to add up to a negative 7. Well, the 2 factors of negative 8 that to negative 7, well, to get a negative factor, one needs to be negative and one needs to be positive. So I'll do a negative 8 and a positive 1. Negative 8 plus 1 will end up being a negative 7, like what I want. And the question is, how is that going to help me? Well, the negative 8 and positive 1 will help me break down that negative 7 x into 2 pieces. Let's see. So it'll break it down into a negative 8x and a positive 1x. I have to leave my first piece, the 2x squared, alone, and the last piece, the negative 4, alone. But now I've got 4 terms, so I can do grouping. What do the first 2 have in common? Notice that the first 2 terms are both divisible by 2 and both have an x. So if I factor out both a 2 and an x, I'll still have one more x in that first piece. Minus 2 will go into 8 4 times, and I did pull out the x, so that will be gone. The second 2 terms, I'm going to pull down my plus. I don't see anything in common, so the only thing I can do without changing anything is to pull out a common factor of 1. Dividing out a 1 or factoring out a 1 leaves everything the same. So that will leave me with an x minus 4, which is perfect, because then notice my x minus 4 does match up on both pieces. So I can factor out my matching x minus 4. And then my leftovers will go inside of a new set of parentheses. Well, what will be left over when I pull out a matching x minus 4 from both pieces will be the 2x plus 1. And that will be my final answer, is x minus 4 times 2x plus 1. Let's take